Did you integrate that to confirm? Lena? You better. Take that, separate like I did before, your changing terms and integrate. Okay, let's do an example, can we?
No.
I'm going to show you this, and then I actually made the graphs for these so you didn't have to. Number 43.
Link to the graphs.
No, you can just write down for yourself this is number 43. Then you can refer to the notes. Oh gosh, the graphs wouldn't be on the my PowerPoint notes. 43 is right there. I chose 43 because I expected that most of you have been concerned about the dimerization of butadiene. So I thought you'd be interested in this one.
Totally.
Yeah. Totally what I do in
so.
my free time, searching out dimerization.
So, the dimerization of butadiene is studied. We have one reactant here, so we can find out what the order is with respect to that reactant. Here are the concentrations. Notice the concentrations going down as time goes on because it's being used up. The reactant's being used up.
What exactly is dimerization? Oh, you put those
Polymerization, but just two molecules coming together. It makes a dimer. A trimer would be three monomers coming together.
That'll be like
What's a monomer?
16 or something.
What's a monomer?
Don't do that to me.
I forgot my house.
Okay, so as usual it says, determine the rate law, the integrated rate law, and the value of K. You have to do that a lot. We can find the integrated rate law. Anytime you have concentration versus time data, you can find the integrated rate law. But that's where we grab our calculators with the handy graphing functions, or we run to our computer and go to Excel, or your iPad that has a spreadsheet that'll graph for you, maybe. Or you could grab a sheet of graph paper and do it by hand. Sophie, that's a great idea. Great idea. All right, so
Great idea. So
now you don't have to have all this memorized or written down. I already have written down this on an Excel spreadsheet. Let's take a look. Oh, here it comes.
So you don't have to graph that?
Ooh, fancy.
So here's our data that the book gave us. Our time data and the concentration of C4H6. I graphed that. That's right here. Let's see. I graphed the concentration versus time, and what do you get?
It's not
You get
straight
some
line.
curvy, non-straight line. What does that tell us?
It looks pretty
The zoom dial's messed up.
Oh, that doesn't end up.
It's not true.
This is just concentration versus time.
Oh, it's not zero.
It's not zero order. Remember, concentration versus time tells us it's a zero order. If it's straight line. This is not first order. This is not zero order. It's not for. It's not zero order. Yes, it's not zero order because the concentration versus time, which is what we look for in a zero order reaction, it's got to be a straight line. This is not. Okay. So I'm going to can that one, and then I went to natural log. I said, okay, it's not zero order, maybe it's first order. So I took the natural log of each of these numbers, and I'm going to graph the natural log versus time. See that? So that's this graph. And I got that.
No,
That is UG.
not. It's not
Is
first.
that linear?
No,
Kind of. Not really.
it's not.
Are
so
you
it's
sure
not
it's
first.
not really, or is it just a delusion?
No.
It's not. You're convinced
It's
that it's
not.
not. There is something that you can do. Now, many of you have not yet had statistics. Do you have it this year? You done linear regression?
Yeah.
Good. So you can, if you have an Excel graph, you can do this on your calculator. I don't have any idea how to do it though.
Why not?
Right-click on
Yeah,
the
that's smart, right?
plot in the Excel. If you right-click on it, one of your choices is Add Trend Line. Go ahead and click on that. You can do two things there. Display the equation. It's going to tell you what the equation is for the best fit line. And the last thing says R squared. It's called linear regression. The R squared value, if it's close to 1, or if it is 1, that means it's a perfectly straight line. If it's close to 1, that means it's almost a straight line. So we have it. And Excel is usually nice enough to put it right across the graph so you can't read it. So there's our concentration equals negative K times, well this says X, but it should be time, plus the Y, minus the Y intercept.
Wait, that's supposed to be X.
The R squared value is 0.98 something. So 0.9, you think, wow, 0.98 is pretty good. This is a good candidate for our straight line. Let's take a look at the second order though, just to see if it's even straighter. Yeah.
That's pretty strange.
Chi-squared. Chi-squared is statistics, and I don't think though it has anything to do with R squared.
Oh my god.
You don't want to know.
You can't remember.
You don't want to know.
I remember the R squared. I don't know how you- They take different points and they on their line of best fit, and they see how far it is from the connected lines. I think that from the points, they take the perpendicular to all the points.
Actually,
It's like a
Orientation
statistician,
stats next.
but I don't remember exactly what it is.
Wait, Mr. Moore.
What?
Like those numbers, are they like, do they stop at that place or do the numbers go on?
Do they stop there and there?
No, as in data points, decimal places.
Oh yeah, I have no
You
idea.
know why?
They probably keep going.
Okay, so I mean, if it could be more than, it could be a straight line.
it's really easy to do.
It should be an arc.
No, no, because that you can tell definitely that's off the line of best fit. Even if that number kept going, it's not going to move that by hardly anything. No, it's not going to give you the best fit. Just because we're rounding. Okay, so I also then went to take the inverse of the concentration and plotted that versus time. If that gives us a straight line, then the reaction is second order. Let's take a look.
You already got the.
Oh my god.
Is that straighter than the first order?
Yeah.
Let's do a regression on this one and see. Looks like that spot right there. I'm not so convinced that that is straight.
It's like a tiny.
I told you the zoom dial's messed up.
Not a chance. You can just find R squared. This R squared is 0.9995. So I like this one better than the first order one. That tells us this reaction is a second order reaction. And it asks us to write the rate law. Remember what the rate law looks like. I asked you to write that down. It's the inverse of the concentration, 1 over C4H6 equals positive KT. By the way, the second order is the only one that has a positive slope. These both have negative slopes. Kind of hard to see them now. See, it's got a negative slope, and that one's got a negative slope. Ah.
Oh, but that makes no sense because
It does make sense because this is the concentration of the reactants. During the reaction, the reactant concentration is going down. So we should have negative slopes. What about for this one then? Why is this graph going up?
Because it's the inverse.
Because it's the inverse of the concentration. And as the concentration goes down, its inverse is going up. Yeah?
Yeah.
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 So that's why this slope is positive for second order, but it's negative for the other two. And you'll see that when that was derived, that was built in. 0 in first order had negative KT for that thing, but second order has positive KT. Plus 1 over C4H6 initially. That would be the integrated rate law for that reaction. That's fun.
Wait, how are we supposed to do this?
when you give us the graphs.
How are we supposed to do this on a test? Do we have time to grab a sheet of graph paper and X, Y, and that whole shit? Not a chance. I would give you the...
You didn't say what I think. Like,
Yeah, I think I might have said that wrong. Let's strike that. You're not going to have to do any graphing. I would give you the graphs on the quiz and the test. Even on the quiz, some of these questions...
We're all absolutely mesmerized.
I didn't mean to say that anyway, so I'm like...
he's one of the cool people.
You know how when I get excited, I start talking fast, I lose it. On the quiz, you're going to have some questions like this for homework, and so I may, think these are fair game. But I would give you the graphs.
Oh.
With the R squared.
So I give you
The words
these.
above.
And you have to decide which one is straight and what the...
Wait, would you give us the R squared?
Yeah?
The R squared.
I probably wouldn't give you the R squared. Now, listen please.
Oh, yeah.
On the tests and quizzes, you have a very short amount of time, so I couldn't expect you to graph. For homework, though, I expect you to have an unlimited amount of time. So I do want you to try some of these on your own. I'm going to give you the last part of the hour, 7 minutes or so. I want you to snuggle up with someone that has a graphic calculator. Maybe you have one and you don't know how to use it.
Anybody need a person?
See if you can determine how to find, let me see what I do here. Determine the rate law for this one. That hydrogen peroxide problem. Over here. I told you we were going to come back to this. What is the order? Is it zero order, first order, or second order for this data? That means the first thing you want to do is just plot the concentration versus time. If that's a straight line, then you're done. You know it's first order, zero order, and you can stop. But I will tell you that the most common order is first order. By far the most common is first order. So don't be surprised if your zero order plot is not straight.
Yeah.
What's their power minus one?
Should we just go with
Yeah, ignore that part. That's the Zubals being clever.
Sorry.
We're going to be over and out on the video. If you're watching this thing on YouTube, try this on your own, and you can talk to me later about what the actual answer is. Or you can just look it up in the solution guide.
Go
Coming through the
cameraman.
site.
Yeah. So,
And we're
stop
up.
it.
Thank you, Bruce.
Okay.